What if I told you that within 30 seconds of taking your first sip of alcohol, molecules from that drink can already begin affecting your brain, and before the night is over, nearly every major organ in your body will have been involved in processing it? Right now, imagine holding a glass of alcohol in your hand. It looks simple enough. A clear liquid. A common social drink. But the moment it touches your lips, an extraordinary biological chain reaction begins. As the alcohol enters your mouth, your tongue immediately detects its unique chemical properties. Tiny taste receptors send signals racing to your brain, preparing your body for what is about to arrive. Even before the alcohol reaches your stomach, your nervous system is already responding. Then comes the swallow. The liquid slides down your esophagus, pushed by rhythmic muscular contractions deep inside your body. Within seconds, it reaches the stomach, where many people assume digestion begins. But alcohol behaves differently from most foods. Unlike a sandwich or a piece of fruit, alcohol requires very little digestion, and that's where things start to get interesting. Inside the stomach, alcohol begins passing directly through the stomach lining and into nearby blood vessels. The rest continues into the small intestine, where absorption becomes even faster. Tiny finger-like structures called villi dramatically increase the surface area available for absorption. Now imagine millions of alcohol molecules slipping through these microscopic structures and entering your bloodstream. At this point, the journey accelerates. Your circulatory system becomes a high-speed transportation network. With every heartbeat, alcohol is carried throughout your body. Red blood cells rush through arteries, veins, and capillaries, delivering alcohol to nearly every organ. But where is it heading first? One destination stands above all others. Your brain. Unlike many substances, alcohol can cross the blood-brain barrier, a highly selective protective shield designed to keep harmful compounds out. Yet alcohol slips through surprisingly easily. Moments later, it begins interacting with billions of neurons. Communication between brain cells starts to change. Signals that normally travel with precision become altered. Certain neurotransmitters become more active, while others slow down. This is why people often feel relaxed after a drink, but relaxation is only part of the story. As alcohol continues affecting neural pathways, reaction times can become slower. Decision-making may become less accurate. Coordination can begin to decline. The very organ responsible for judgment becomes increasingly impaired, often making it harder to recognize the impairment itself. And while all of this is happening in the brain, another organ is preparing for an enormous workload: the liver. Think of the liver as your body's chemical processing plant. Its mission is to remove toxins and maintain balance. As alcohol arrives through the bloodstream, liver cells immediately get to work. Special enzymes begin breaking alcohol apart. First, alcohol is converted into a highly reactive compound called acetaldehyde, a substance even more toxic than alcohol itself. Then another set of enzymes steps in, transforming acetaldehyde into acetate, which can eventually be broken down into water and carbon dioxide. But here's the problem: the liver can only process alcohol at a limited rate. If alcohol enters faster than the liver can remove it, the excess continues circulating through the body. This is why drinking more doesn't speed up the process. No amount of coffee, cold showers, or wishful thinking can force the liver to work significantly faster. Meanwhile, alcohol's influence continues spreading. Your heart responds as blood vessels expand and circulation patterns change. Blood flow increases to the skin, creating the warm sensation many people experience after drinking. Even though the body may actually be losing heat more quickly, your lungs continue exchanging oxygen while carrying alcohol-containing blood throughout the body. Your muscles receive this altered blood supply as well. Cellular energy production begins to shift. Coordination and reaction speed may decline as communication between nerves and muscles becomes less precise. Then the kidneys enter the story. Alcohol suppresses a hormone that normally helps your body conserve water. As a result, your kidneys begin producing more urine than usual. This is why frequent trips to the bathroom often accompany drinking. And here's where another problem emerges. As more fluid leaves the body, dehydration can begin developing. Headaches, dry mouth, fatigue. Many symptoms associated with a hangover actually start long before the next morning, but the effects don't stop there. Deep inside the digestive system lives an enormous community of microorganisms known as the gut microbiome. Trillions of bacteria help digest food, support immunity, and influence overall health. Alcohol can temporarily disrupt this delicate ecosystem, altering the balance between beneficial and harmful microbes. At the same time, immune cells throughout the body may respond to alcohol exposure. Inflammatory signals can increase. Tissues can experience additional stress. The body begins dedicating resources to restoring balance. And what about energy? Many people assume alcohol provides energy because it contains calories. Technically, it does, but alcohol also interferes with normal metabolic pathways. Cells often prioritize processing alcohol over other nutrients. This can disrupt the body's usual energy production systems and contribute to feelings of sluggishness later on. As blood sugar levels fluctuate and dehydration progresses, another familiar phenomenon may appear: the crash. The temporary relaxation or stimulation experienced earlier can give way to fatigue, reduced alertness, and lower energy levels. The body is now dealing with the consequences of a substance that has traveled virtually everywhere. Your stomach has encountered it, your intestines absorbed it, your bloodstream transported it, your brain responded to it, your liver processed it, your kidneys filtered around it, your muscles adapted to it, your immune system reacted to it, and your microbiome felt its presence. Yet despite all these effects, the outcome depends enormously on factors such as body size, genetics, food intake, hydration, drinking speed, medications, and overall health. The same amount of alcohol can affect two people in very different ways. That's one reason alcohol remains such a fascinating substance from a biological perspective. A single drink can trigger a body-wide cascade involving chemistry, neuroscience, physiology, metabolism, and cellular communication all at once. So the next time you see a glass of alcohol, remember, what appears to be a simple drink is actually the beginning of an incredibly complex journey. Within minutes, countless biological systems coordinate, adapt, and respond as your body works tirelessly to process every molecule. And perhaps the most surprising fact of all, long after the last sip is gone, your body may still be working behind the scenes, repairing, rebalancing, and returning itself to normal. A journey that begins with a single swallow becomes a full-body story, one written inside you, molecule by molecule, organ by organ, until the very last trace of alcohol disappears. Subscribe, like, and thank you for watching.